Welcome back. This is the solution to James Stewart's early Transcendentals 8th edition, section 1.1, question number 22. Forewarning, I hate doing graphs, and so I purposely did a pretty lazy job on making these graphs. They look pretty awful. For the first question here, question number 22, it's talking about an airplane. It's taking off into the air, flying for a little while, and then landing in an airport some distance away. It's asking for 4 different graphs. The first one says x of t, which is basically a fancy way of saying the distance in the x direction versus time. So we have to put distance in the x direction on the y column, which probably seems a little bit counterintuitive, and time on the bottom. Initially, I make it so it looks like it is increasing at a very slow rate, and the reason why is because it's probably barely moving. More than likely, for the first couple of minutes, you're sitting on the track waiting to take off, and then when you do take off, it's kind of a pretty steady progression from then on. Yeah, because basically you reach a constant speed and you just fly through the air for the remainder of the trip. The next question is a little bit more complicated. It is asking for the vertical height. So generally what happens is you take off, you climb for a little while, and then you reach what's called cruising altitude. You stay at that fixed height for a while, and then you finally come down at the end. And that's kind of what this graph represents. Cruising altitude is about 12,000 meters or so. Finally, this one is a little bit more complicated again because it's asking for velocity or speed. And so initially when you're doing your little takeoff, you're going to be accelerating from a stop and driving around the tarmac, which is going to be pretty slow. Then you're going to pick up speed a little bit as you're climbing in the x direction. And then finally, once you reach your cruising height, you're going to be going at a pretty constant speed in the x direction until you decelerate. And finally, this last one, which I'm running out of time to speak for, because I didn't time this video very well, is a graph of the vertical velocity. Now, initially, your vertical velocity is not increasing at all because you're driving around the tarmac, so it's 0. And then your vertical velocity is increasing, probably about 20 meters per second for about 10 minutes, which will put you at 1200